For only the third time in recorded history, astronomers have confirmed the arrival of a new interstellar visitor, an object that originated from another star system entirely before making its way into our solar neighborhood. This remarkable celestial traveler, first labeled A11PL3Z and now officially designated 3I/Atlas, was detected on July 1st by a powerful survey telescope in Chile. Its discovery was so compelling that, on the very same day, the International Astronomical Union's Minor Planet Center verified its existence and classified it as an interstellar comet. To better understand its path, astronomers searched through archival sky images and found that faint traces of the object had actually been imprinted on older observations dating back to mid-June. These earlier sightings allowed scientists to reconstruct its trajectory with greater accuracy, revealing a motion so straight and so rapid that there could be no doubt. This object is not bound to the Sun by gravity, nor has it ever been part of our solar system. Instead, it has come from the deep interstellar void, a relic of another star system that has been wandering through space for possibly millions or even billions of years before intersecting with ours. What has particularly intrigued astronomers is the sheer scale and speed of this visitor. Estimates suggest that 3I/Atlas could be as large as 20 kilometers in diameter, making it considerably larger than either of the two previous interstellar objects ever detected. At the moment, it lies just inside the orbit of Jupiter, speeding inward on a trajectory that will bring it closest to the Sun in October. Unlike many comets that loop around the Sun in elliptical orbits and remain gravitationally tethered, this one is flying straight through like a cosmic bullet, destined to exit the solar system again once its brief passage near our star is complete. Its velocity is so high that the Sun cannot capture it, meaning it will not return after this encounter. To appreciate how extraordinary this discovery is, it helps to recall the first two known interstellar objects. The earliest, discovered in October 2017, was the now famous Oumuamua, a strangely shaped, elongated, asteroid-like entity that entered our solar system from the direction of the constellation Lyra. Oumuamua fascinated the world because it behaved unlike any other known asteroid or comet, with unusual acceleration and an appearance so faint that astronomers struggled to classify it. Unfortunately, it became visible only after it had already passed the Sun and was rapidly leaving the solar system, giving scientists barely 2.5 months to observe it before it faded from view. This fleeting window led to numerous scientific debates, hypotheses, and even a few unconventional speculations about its nature. The second known interstellar object, 2I/Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov, turned out to be a much more typical comet in composition and appearance, though equally exotic in origin. Coming from the direction of Cassiopeia, it provided valuable data because it was detected earlier in its inbound journey than Oumuamua had been. Yet even with 2I/Borisov, astronomers had only a limited time to gather observations before it too receded into the depths of space. This is what makes 3I/Atlas so profoundly exciting for the scientific community. According to Pamela Gay, an Illinois-based astronomer with the Planetary Science Institute, this is the first interstellar object detected while still on its way into the solar system rather than after its closest approach to the Sun. This early detection gives astronomers something they have long dreamed of: time. Time to plan observations, coordinate telescopes across the globe, analyze its behavior as it begins to warm under the Sun's influence, and study how its surface and tail evolve. Scientists anticipate that 3I/Atlas will remain visible from Earth until at least 2026, meaning this event offers an unprecedented opportunity, a multi-year window, to observe an object born around another star. However, this extended observational period does not mean astronomers are relaxed. Quite the opposite. As Chris Lintott, a prominent astronomer at the University of Oxford, explains, there is a sense of urgency surrounding the object study. The goal is to observe 3I/Atlas while it is still relatively cold and pristine. As it travels deeper into the inner solar system and its temperature rises, solar radiation will begin to heat its surface, causing volatile materials to sublimate and potentially altering its structure. While this can provide valuable data about the comet's composition and behavior, it also risks erasing the physical and chemical signatures that have remained unchanged since the comet formed in its original star system. Researchers want to study it in this untouched state because it preserves the conditions of a planetary system other than our own, a cosmic time capsule that holds clues to how planets and comets formed elsewhere in the Milky Way. The chance to study material from another solar system is extraordinarily rare. As Gay emphasizes, observations of 3I/Atlas may yield insights unavailable through any other method. Scientists cannot travel to other planetary systems, nor can samples from them reach Earth under ordinary circumstances. Interstellar comets, like 3I/Atlas, are the only naturally occurring messengers capable of delivering physical evidence about distant systems to our doorstep. By analyzing its composition, its ices, dust, organic compounds, and gases, astronomers hope to better understand how planetary systems throughout the galaxy evolve. Does planet formation follow similar processes everywhere? Or do the building blocks of planets vary from star to star? Is the distribution of water and organic materials similar across systems? These are monumental questions, and each interstellar object provides a unique piece of the puzzle. The arrival of 3I/Atlas is also stirring excitement among a broader community of scientists and astronomy enthusiasts. In recent years, the role of citizen scientists, amateur astronomers who contribute observations and data, has grown significantly. Their involvement, combined with the introduction of advanced observatories, such as the Vera C. Rubin Observatory in Chile, is expected to revolutionize the discovery and study of transient objects in the sky. The Rubin Observatory, scheduled to begin collecting scientific data this year, will conduct deep, wide-field surveys of the night sky with unprecedented sensitivity. Many experts believed that the next interstellar object would be discovered only after this powerful facility became operational. That is why Lintott recalls laughing when he heard about 3I/Atlas merely half a minute after waking up. It felt like a cosmic surprise, a reminder that the universe still has the capacity to astonish even those who spend their lives studying it. The unexpected timing of the discovery has sparked optimism that such interstellar encounters may be more common than once thought. For decades, astronomers suspected that objects like Oumuamua and Borisov might be drifting through interstellar space in large numbers, flung out of young planetary systems during their chaotic formation periods. However, detecting them has always been extremely difficult because they are small, faint, and move quickly across the sky. The fact that 3 have been identified within the span of just 8 years suggests that the tools and methods for spotting them are improving, and that many more may be passing through unnoticed. With technology rapidly advancing and the Rubin Observatory soon joining the hunt, the frequency of discoveries may increase dramatically. Every new interstellar object that enters our solar system provides a rare window into the broader workings of our galaxy. These travelers are remnants of distant worlds shaped by alien suns and sculpted by gravitational interactions that happen trillions of miles away from Earth. Their journeys across interstellar space expose them to cosmic radiation, collisions, and chemical processes not found within our own solar system. When such an object suddenly appears among our familiar planets, it grants humanity a fleeting opportunity to study something profoundly foreign without leaving our cosmic backyard. The arrival of 3I/Atlas, therefore, is more than a scientific event. It is a moment of wonder, a reminder of the vastness of the galaxy and the mysterious forces that govern the creation and evolution of worlds. As astronomers prepare for years of intense observation, the global scientific community feels a mixture of excitement, curiosity, and determination. They know that 3I/Atlas will not linger forever, and once it leaves, it will disappear into the darkness, unlikely ever to cross paths with Earth again. Yet in the brief time it remains with us, it has the potential to expand our understanding of the universe and deepen our appreciation of the cosmic environment beyond the boundaries of our sun. Its presence is a testament to the dynamic, interconnected nature of the galaxy, A reminder that star systems, though separated by unfathomable distances, are not isolated. Material drifts between them, carrying the stories of their formation and evolution. In studying 3I/Atlas, we are, in a sense, peering into the history of another star's family of planets, learning not only about them, but also about ourselves and our place in the vast expanse of the cosmos.